This video has been made possible through the support of our museum members. To become a member, visit charlesrivermuseum.org/join. Please subscribe to follow us here on YouTube and hit like if you enjoyed this video.
Well, when I get home, I'll watch this and I'll hit like.
All right. Hello, everybody. I want to welcome you, first of all, to the Charles River Museum of Industry and Innovation. My name is Bob Perry, and I'm the museum's executive director. And right there is Bob Timmerman, who's tonight's presenter. What we have set up for you tonight is about a 17-minute pre-recorded video where he does explain the combination square, does do some demonstrating. And then we will switch gears to live. But right now we're going to begin with a video that should get you all up to speed and get you curious to learn more.
I'm standing here in front of the measurement exhibit in the Charles River Museum, and measurement is one of the very fundamental things, both in science and technology, that basically one has to measure something in order to define its properties. And in measuring length, the first thing you need is standards of length. And we have here a set of gauge blocks, and these are very precisely made blocks of steel or later on carbide. And they are assembled in various combinations to make standards of length for calibrating gauges. And then, once one has a definition of length, one can measure length, and we have a series of micrometers. And then we need to usually define angles and right angles and to lay things out. And for that we use combination square. And the museum has examples of combination squares. In this exhibit, we have a fairly old square and the center head. And these somewhat different versions will be the topic of the presentation on the combination square. Hello, I'm Bob Timmerman. I'm a museum volunteer. I'm trained as a mechanical engineer, and that's what I have had for my whole career, mechanical engineering. I'm also an amateur machinist and amateur carpenter. I'm here today to talk about one of my favorite layout tools, the combination square. We have a combination square set in our measurement exhibit, and I'm bringing in some of my own squares to give an in-depth look at what the combination square can do. This is a combination square. This one is made by Brown and Sharp, and this is the one actually out of my machinist toolbox. A little history here. Before we had combination squares, we had just a regular straight square, and they were limited to checking just whether something was square. For example, I can put it up against this board and I can see that the cut is almost square, but it's out by maybe 10,000ths of an inch, which would not be acceptable for fine cabinetry, but it's more or less okay for woodworking. but we needed more. We needed a tool that had far fewer limitations. And a little history here. In 1877, a man named Leroy S. Starrett invented the combination square, and he took his invention very proudly to Brown and Sharp, who was a leading builder of both machine tools and precision instruments in Providence, Rhode Island. He asked them if they would like to make them under license, and they looked at it and they scoffed. We can't make this to anywhere near the degree of precision that's necessary for this to be a useful tool. And Mr. Starrett had another shop make 5,000 of them. They sold pretty well. And so in 1880, he went into business for himself in Athol, Massachusetts, making initially combination squares and then later other precision tools, and became a major competitor to Brown and Sharp. Brown and Sharp's business faded away due to being at the wrong place at the wrong time, I think. And now they're a subsidiary of somebody else. They're out of the machine tool business, but some of their precision tools are made in Switzerland, and rules and perhaps combination squares are still made in the US. The Starrett Company, and this is a Starrett combination square, is still very much in business in Athol, Massachusetts, making much larger variety of tools than just combination squares. So now I would like to show you the reason the combination square is such a versatile tool. This is a hardware store tool. It's actually a Sears Craftsman tool. It doesn't have anywhere near the accuracy of these, but it's an easy tool to demonstrate. Now, we have a blade that has graduations on it, and I'll talk about them in a minute, both sides, and it's got a slot, a groove in it, and there is a lock bolt that goes into this groove, and this is not really precisely made, and then the lock bolt goes into the square body, and with a nut on the other end of the bolt, it holds the blade into the square body. Now, this is a precision-made tool, bought in about 1975, and this, as you can see, slides very easily, and just a slight turn holds the blade in place. And with a movable blade, you can do lots more things. But let's talk about the blade. It's got 1/8 and 1/16 on one side, and then 32nds and 64ths of an inch on the other side, and this is a very common graduation. You can also get 50ths of an inch and 100ths of an inch, although the hundredths are a little hard to read. But the square head itself has both very accurate square. I've checked this against another square, and basically this is square like this to about 1/1000th of an inch out here, which makes it accurate enough for all but the very most precise work. In addition to 90 degrees, it has a 45-degree angle, and it's got a level. Now, the level is not intended to be a super precise machinist level, but it's good for fast setups. And all the squares also house a scriber. It's housed in a little pocket back here, so it can be readily accessed. Now I'm going to demonstrate what you can do on a piece of scrap lumber, because I use the square for laying out on carpentry. This is a fairly inexpensive one, and I actually have one similar to this in my finished carpentry box, which I use both for layout and checking my power tools. Well, obviously, we can do a straight line. Now this is perpendicular to here. We can then, by adjusting this, I can get a longer line here, and then I can do a line at 45 degrees, and talk a little bit more about splitting that up later. I've got standard size. I've got a longer blade that will fit that body. This part of it's a little short for this blade, but I've used it in some applications. That's also handy as a 24-inch straight edge. They come smaller. This is a very handy size. Now this is a Starrett, made a little differently. Starrett company has a somewhat different opinion of how these things should be made. But this is very useful for small objects, as I'll demonstrate shortly. Fits easily in a toolbox, and I've got a couple of these tucked away in some toolboxes for small work. Now the next tool is the protractor. Oh, one more thing before that is that with the level here, and I'm going to make my photographer's job difficult, I can check, and this bench is almost level, and I can then, if we adjust this so this is level, we can show that not only is this not perpendicular to the bench, but this shelf at the back isn't plumb. So this allows you to check plumb as well as level. Now, the protractor is standard Protractor Zero. Here is with the blade and the protractor head aligned, and then it measures up to 90 degrees. I've set this to 22.5 degrees, so I can split that 45-degree angle and actually, since you have 90-degree pipe fittings and 45-degree pipe fittings, there are some special fittings available at 22.5, and if you wished, you could check if they were made right with this. Because you have a level, you can also use this to check the angle to the horizontal. And I'm actually going to be using this tomorrow to verify the pitch of the roof of my house for that very reason. So there we have it. We've got a standard level, standard square, a large square, and a small handy square. But the combination square can do one more thing. Well, it can do two more things. First of all, if you need to do a line parallel to another line to the body of a piece of work, then you can set the blade. And I'm going to set this to 1/2 inch, and I'm going to use this to scribe a line parallel. So this is, let me set this to 1/2 inch. This is set to 1/2 inch, and I'm taking the scriber out of the pocket here. And now, this is handy both in metal and in wood, because you've now got a line parallel to this edge, done very quickly, very easily. And that's one of the primary things that I use the combination square for. Now, we have a number of lathes in this shop, and one of the things that you sometimes have to do is very accurately turn something on the lathe. Instead of relying on the chuck, you put it between centers, and centers are two accurate points that stick into each end of the lathe, and they hold the work very accurately, and then you drive it with a lathe dog. And what you need to do this, you need to find the center of the work. And for this, we have a tool called a center head. And this is sometimes a little finicky to put on. And this fits into the groove. And I'm putting it right on with right on the square head, with the square head blade on there for a reason. Now, I have coated the end of this with what's called layout blue. It's just a lacquer. It kills the glare so you can see the line better. Now, the angle between this is the blade bisects that angle. And so these are fairly large pieces, and you can put this against a piece of metal and draw a line, and from this angle you can see the line, and then I can draw another line this way, and where these two lines intersect is the center. And then I can very carefully drill that, mark that, and then drill it. And I have the center of the shaft, and I can do the same thing on the other end, and I can set it up in the lathe drill two holes, and I can set it up between the centers, which is a very accurate way of turning. So the combination square can find a center. It can draw a line parallel to another line. Actually, it can do another trick. It can then be used to measure thickness or the depth of the slot, and it's about 28-30 seconds. It can measure, it can draw angles. It's a very versatile tool for laying out, and it's my favorite tool for doing preliminary layout, and also for checking work. I use one of these to set up my table saw and check the accuracy. So that's basically the combination square, and if people have questions, I'll be happy to answer them. Thank you.
What are some of the things a buyer should look for when purchasing a combination square? How can you tell a good square from a bad one? And take it away, Bob.
Well, the first thing is the combination square head should be steel, not die-cast metal like this one. There are two kinds of heads. There's cast iron heads, and there are forged steel heads. And preferably, a forged steel head is somewhat more rugged, less likely to be damaged if you drop it on a hard floor. That's not recommended. And most of mine have forged steel heads. And then the blade should be what's called satin chrome. This is finished with a little chrome finish so that light doesn't reflect off it so that you can read the graduations and so that it doesn't rust. That and just being overall well made. I mean, the tool should feel good in your hand. It should feel smooth as you run the blade back and forth. And those are the main indications. I mean, this is a knockabout tool for rough carpentry, and I've got a couple of these kicking around my shop, but I don't use them for anything precise. But it's cheap and it's handy if you need something that's a knockabout tool. These two sit in protected places in my various toolboxes. I've got two more, one more large one and one more small one that also sit in protected places. So basically, steel or cast iron square head, preferably steel, a well-made blade, satin chrome, and the whole thing should fit together well enough so that it feels smooth as you use it.
A questioner has asked, how do you know if your square is square?
I ran that test before I did this talk. I have two 12-inch squares. Let me just take this head off. Identical. One's a brown and sharp. One's a Starrett, both same quality level. And I put them like this on a surface plate, that is a flat, relatively flat piece of granite, not super precision ground, but flat within 1/1000th of an inch. And I had this square here, and I had another square here, and I butted them up like this. And I was only able to get a 1/2,000th feeler gauge between the two of them. And that told me that probably the error on each of these is about 1/1000th of an inch. You can also, of course, take a reasonably straight edge rather, put the square like this, and then measure this. A line won't be accurate enough. You'll have to use then another measuring device to check the deviation from this end to this end, and then flip the square over on this straight edge and run the same measurement here. But this depends on having a square edge. Checking it against a square also requires another square. Unfortunately, you need another square to check a square, really. You can get an approximate answer by doing a very fine line, but that's probably not going to give you a very accurate answer.
Missed an earlier one. How might you see if the level on your square is accurate?
That's actually a little easier because I'm just not going to take this out, but you can turn the level. You put it on a reasonably level surface. If you've got a machine tool that's been leveled up, that's excellent. And you put it one way, and then you flip the level around, and presumably you're on a level surface. You should see any deviation in level. So that's basically how you check that.
You reverse it.
Yeah.
Next question is, do squares come in larger sizes than the one that you're using?
Yes, I think Starrett makes a 18-inch square that's got a bigger center head and a larger blade, and of course a larger price to go with it. But yes, they come in larger sizes if you really need one.
I'm wondering, Bob, How did you first learn how to use the combination square? Is that something that was taught in school?
I think I learned this in school shop, probably in 7th or 8th grade, and then decided it was a tool I really liked, bought a cheap one, and then later on, when I had a little more money and had a need for something more precise, I bought another, a more precise one. There was this, and this all came as a set with only one blade, and I bought an extra blade. And of course, once you're into the habit, then you find you can't just have one, so I bought a small one, then another big one that sits in my carpenter's toolbox in a protected place, then another small one that sits in a utility toolbox. You find that you need more, and then along the way I acquired a couple of cheapies, which just sit in a corner of the shop where I can grab one in a hurry if I need something that's not precise and I don't want to open up a toolbox and fish something out of a protected place. You got to take care of tools.
I love this question. Let's say you've just been dropped off on a brand new planet where there are no squares yet. How do you generate your first accurate reference square?
Oh, actually you can do this with geometry. You draw a line, and you can then strike two arcs, and the arcs have to be a little larger than half of the middle of the line, and basically you draw one arc like this, one arc like that. They bisect the line, and this is square. And it's basic Euclidean geometry, which some of us studied in, I guess, 8th grade, and hated, but there are certain postulates that are very useful. And that cuts the line in half and gives you a perpendicular, and then you can take that and you can refine it.
What are some signs that you're looking at a cheaply made combination square?
Well, okay, let's look at this. First of all, this is die cast. It's die cast, probably aluminum or zinc. Secondly, when you run it back and forth, it doesn't move smoothly. It's a little rough, and there's no way it really moves smoothly. You take this one, and you open it up, and it just moves smoothly. That's the way it's supposed to work. And of course, this is made in roughly 1975, so the companies making this have had almost 100 years in making it. This is probably a little bit newer. Again, Starrett has had 100 years, and going back and forth, the blade just feels very smooth. This is rough because they didn't go to a lot of trouble to machine it well, and the graduations don't go all that fine. This is 1/8, 1/16, and on this side, it's probably 1/16 and 32nds. There's no 1/64 of an inch graduation, which is usually fairly useful. So that's it. The graduations don't go up all that fine. It's die cast metal instead of machined steel, and it just doesn't feel that smooth. And that's the big tip-off right there.
Bob, do you have any closing thoughts? Anything that doing this talk tonight has brought to mind that you didn't mention in the pre-recording? No pressure.
Yeah. Good, in the long run, good tools are less expensive than cheap tools. If you have cheap tools, they may not be accurate, and you may have to fix the work you've done because the square isn't accurate. The good tools, well taken care of, you do the work once. And also, they last. I bought this when I was, in my 40s. I'll pass this on to my son. And maybe he'll pass it on to his grandson. I have some tools I inherited from my grandfather. Some good Stanley planes and a Stanley bit brace. Good tools last, and they're cheaper. It may be a financial sacrifice initially, but you're paying it back over many years. So I guess that's the closing thought. Buy good tools.